That's the Yamuna introduction part is there. It originates around 4.5 kilometer elevation level. This glacier, Bandapur glacier is there. So it is characterized by two hinterland. One source area is the Himalaya. Another source area is the Cratonic area. Cratonic in geology we call it a stable land mass with an elevation of around 500-600 meter elevation. So it receives fluxes, water, sediment, and nutrients from both the directions, and it flows in this flows and then joins the Ganga river system. It flows around 1,370 kilometers, and the basin area is around 3.5 into 10 to power 5 kilometer square area. So it's a really large river system. Also receives a significant amount of distribution. It is considered as a Himalayan river, and which receives the major discharges there. If you see the rainfall distribution, it is more in a semi-arid condition here, and it is in between, and the Himalayan part is more humid. The slope variabilities, there are some gullies are there, so there's a linear patches, but slope is higher in the Himalayan part where it is flat. The geological variability is there, which will have its impact on the sediment. I will not go in that much of the details. It's only to highlight that the differences are there. So what I'm going to interact is that when it passes through the Delhi area and the Delhi NCR regions, we have at present population is around 20 million people are there. How much the disturbances is there? So the first set of disturbance is come. We know that discharge increases downstream, but here in this part you will see that discharge actually decreases in the Yamuna river. So that's on the y axis. It is a peak discharge data set. We have taken return period flood based on the peak discharge data set. We have taken because in flood time period, we assume that the gates will be open and the impact will be less, but it is not that much. And there is a decrease. After that, it takes a significant jump. There is another set of fluxes which came from the Cratonic areas, and that is responsible for this. I will focus on this part, that what is happening in these regions and how it will impact. Besides this, we also done the ADCP surveys from mountain front to very close to Pratappur, just 100 kilometers upstream of the confluence point, and which shows that the water flux coming from the Kraton area is significantly higher compared to the Himalayan river. So hydrologically, it doesn't behave downstream regions. It doesn't behave like a Himalayan river system, and it behaves more like a Cratonic or peninsular river system is there. That is hydrological data that is there. So 20 years CWC data set, and then 1 year of our cross-section data set support that part. So what is the impact of that hydrological variations? And for that, we have to look for the water flow in the stream part, as Datta is highlighted, that it is not only the water, but the flow of energy is there that is responsible for the work. And for the geomorphic work, we use the stream power, that where we take the power as the rate of energy expenditure, and the rate of potential energy we then take is considered, and finally get the function of stream power as a discharge and slope. And also unit stream power, I think something. So unit stream power we then divide by the channel bit. So this type of profile we can now generate with the GIS data set. There the modeling approaches is there. So what is it shows? This is the plot for the Yamuna river, and the red color is the stream power distribution plot. Blue color is the specific stream power plot, and then green colors are the channel bars present in this thing, which highlight that what is the geomorphic diversity is there. So the green color indicates this is close to the Delhi regions where the large bar is there, sand mining is also there. That is another set of the anthropogenic impact. But yes, there are the large bars which are present in this part. But downstream where the stream power gets down, there is a very less amount of the bars are there, which is anomalous, because with the decrease in stream power, this bar area should increase, but there is not much of the sediment which is transporting. Then further downstream, there is a river confluence coming out from the Kraton area, Chambal, Kain, Betwa rivers, and it is again bringing huge amount of fluxes, and then river get rejuvenated. So in the older work, we have defined the river into three major parts. Natural reaches is there, and the anthropogenic, where it is not behaving like a energy which is there in this case. And then rejuvenated reaches are there, which is coming because of those parts. And here you can see this is the downstream part after confluence of the Chambal. You can also see the sand has been changed. It is much more pink color because of the granitic origin of the sand, and whereas the Himalayan sand is much more grayish. Also grain size variation, we find that in the downstream part, the grain size component actually governed by the cratonic part is there. So grain size part also shows that it is the more peninsular nature or cratonic nature is there compared to the Himalayan part. And this is showing that the river confluence, if you see, so the light blue color is the Yamuna river, which is we call that Chambal is a tributary of Yamuna, but if we look for the fluxes, it doesn't look like. So Chambal is bringing 3 times of the more sediment load at the confluence point and 10 times of the more discharge is there. So in terms of flux, downstream part, whatever is the connection or disconnection is there upstream, at downstream it is that take over by the cratonic nature of the river system. It is not a Himalayan part is there. To understand it further, if we look for the sediment distribution, this is the suspended sediment load data set of the 10-year data point, and it has been plotted. So first plot is showing only for the upstream part. Number 3 is the Delhi region is there. So what happened from the Himalayas, some sediment around 2 million tons of sediment is reaching the part. Some more sediments accumulate from the agricultural land. There is a peaks at the different levels, and the dark blue color is the average value. And then there is a throttling which is happening is there. So number 3, which is just downstream of the Delhi region is there. So not much sediment has been bypassing from this part. Another set of sediment is coming again from the agricultural land. So there is a disconnection of the sediment transport capacity. And if we further extend it, actually the more and more sediment is coming from the Craton area. And this point is indicating a major disconnection. So a major river like Yamuna is not able to overcome the challenges which it faces because of the Delhi NCR regions, because we have highlighted that the discharge has been accommodated. Now discharge has then affected the sediment transport. Sediment transport is affected by the threshold condition. So once the threshold get lower down, there is a major impact on the sediment transport processes there. So there's lots of work on the water qualities there. People have suggested that in Delhi and downstream Delhi river is close to the dead river. But in the morphologically, geomorphologically also, we can see that not much action is taking place. It's not that much alive on this part. It's get rejuvenated further later on. Then the assumption was that maybe during flood time period it will get connected. So we have taken some of the major flood event, and these are the pulses which is coming out from the Himalayas region, blue color. So these 2 plots are indicates that Mavi and Mohana are the station which is upstream and downstream of the Delhi areas. So there are some of the erosion pulses which are coming from the Himalayan area, but it get diluted. Not erosion. This is the hydrological pulses which is coming, and then it's get diluted downstream of the Delhi area. And its impact on sediment transport is further significant. You can see a large pulse is there. So all the flood pulse has generated an erosion waves, erosion pulses are there. But the sediment signal gets diluted. It is become a natural signal is there. So the process-wise, the upstream processes are not getting diverted to the downstream system. And more than hydrologically, geomorphologically, it's a major disconnected system. Even during the flood time period is there. One more data set I will present to highlight the disconnectivities. On the y-axis is the sediment concentration, and it is these are again some of the major events which indicates it may be cloudburst, it may be land use land cover changes, but all these events actually gets merged out. So a system, when we think about a connected system, then a signal should bypass this part. This river is not behaving like a Himalayan river system, and downstream of Delhi, it is not showing any of the signature or related to the upstream part is there. In the geomorphic literature shows to sink approach is very common, that we analyze the sediment in the sink and try to interpret the source processes. But in the case of disconnection, it is not that important. Same thing is that about the river management application part is there. Then which part needs to be focused, that is important, because to look for the disconnection part is there. So it is geomorphologically disconnected, and then signal is not passing through this part. So what needs to be done, and where are the major gaps are there? So for that, then we also look for the vertical connectivity part. Till now, I have only talked about the longitudinal connectivity, and then the agriculture component is showing that the lateral connection was there at the reach scale. But hydrologically, what is the role of groundwater component on those processes? To understand this part, groundwater surface water interaction, we look for the hydraulic gradient going into the field, measure the groundwater level and river space measurement, and look for the in terms of the elevation drop, where is the gradient, and also look for the stable isotope data set and then work on the mixing model. So analysis was done from the mountain front to close to the Faridabad area, so that we can see up to downstream of the Delhi regions in the part. And that's the methodology was there. Two field trip has been done pre and monsoon. So at every time we have collected one data set from the river and four data set from the groundwater. On the left bank, 1 kilometer and around 2 kilometer point, and 1 to 2 kilometer point is there, so that we can find out what is the elevation difference between water and groundwater is there, and these are the about the data collection part is there. So that was what came out. It was interesting result is there, and these are the data set is showing that there is no such defined pattern is there. There is a variation in terms of connectivity between the groundwater and surface water. So somewhere groundwater is higher and somewhere groundwater is lower. So somewhere river is gaining, somewhere river is losing, and that indicates this kind of variation is there. So the blue color indicates that river is gaining water in this case and get from the groundwater, but it is also losing some of the places there. In the Delhi NCR region, it is mainly losing its water is there. How much water is losing? Then that for that we have done the stable isotope analysis, and all analysis has been done at PRL. So there are the other many detailed work has been done generating a plot, but here I will only highlight the river water contribution which has been generated from the isotopic mass fraction equation. So M1 and M2 fraction are two unknown, and we have developed these. These are the two equations there, and this is a standard method in isotopic work. So delta 1, delta 2, delta AMs are known from the estimation, and on this basis M1 and M2 have been determined. And this shows that our isotope data set, first thing is matches very well with the field data set. So regions which are losing, it is showing that kind of loss is there, and the loss is quite variable. So some of the places it is around half of the water is losing, but at the midstream part there is a loss, but it is insignificant. So river is showing more or less a consistent pattern from mountain front or from the Hatnikund barrage is there. So from barrage to up to the Delhi region is there. But in Delhi part, it's a significant amount of loss is there, water. And then again it started getting for the downstream part is there. And the variation is coming around 22 to around 70% is there. So it means that that kind of loss, it is the groundwater which can be used to understand that kind of dynamics, and to understand the river morphology, river dynamics, we have to see the basin in the 3 dimension, and vertical connectivity needs to be analyzed. So before that, I show the result here. What may be the possible causes is there, but this shows that upstream it is losing because there is a post-rain sediments are there, and whenever river passes through the gravel sediments, then it loses the water. But once the sand occupies those areas set, it started regaining, and that's a very traditional definition of the Tarai and Bhavar zone is also there in the system, and that it is matching very well is the part. Canal regions it is losing, and with all the different data set, one major thing which we will think that there is a major paleo channel of the Saraswati paleo channel is going on. It may be losing at water at this case. So we don't have the direct evidence it is happening, but based on the availability of data set, we think that maybe this is the reason that river at this particular location it is losing the water is the case. And further downstream, then it started losing, and then in this part it is much more connected in this places are there. So the anthropogenic stresses are very well clearly there, and then further downstream at the tributary confluence there is the Hindon River joins part, and the water part is not good, but at least the more amount of water is helping us to regain these things are there. So with these things, the impact is that if we plot the return period flood of upstream to downstream, so these are the 3 stations upstream of Delhi region, which is showing that the discharge is increasing, which is expected. But in Delhi areas, this value gets down. So we superimpose that particular number. This is the major gap which is coming out. So seems that the major part is that lack of hydrological connectivity is an important part. Of course, there is a extraction of water needs to be done. So proper The hydrological budgeting, we are still going on, but the initial result is showing that the groundwater contribution is playing a very important role in the hydrological part, and hydrology is governing the sediment transport and morphology. So there is a connection of groundwater versus sediment transport and morphological processes part is there. So that's the one aspect of the disconnection in terms of hydrology and geomorphology part. Second, further downstream, we would like to highlight that once the river then passes through Delhi areas, then what is the impact of those downstream regions? We think that they are not that humid areas is there. But if we look for the major flood, so Araya is a place which is downstream of the confluence with Chambal river. I have shown this part. And major flood actually coming from the Chambal. So during the field visit, we have find that this year there were a flood, but there was no major flood in Delhi. And then with the data set and also with the people were saying, oh no, water came from the Chambal. And this is not just 1 year period is there, but when the data set we have collected, we will also surprised that actually most of the flood events in the downstream part is governed by the cratonic areas. The river is not behaving like a Himalayan river system is the part. So any methodology we could develop for any of the Himalayan river will not be suitable because it's a very, very different river which is there. And this is the flood time period is there. If we look for the average discharge period is there, still an amount of the craton area is much higher, whereas the input from the Himalayan part is less. And in the flood time period it is very, very less part is there. So that was the part I highlighted about the role of disconnection. So there was the one part is that the river and the major NCR, they are fighting for the space on fluxes, and river is losing its worth, and fortunately it receives much more fluxes at the downstream regions. What are its impacts? So to get this part to have a complete understanding, we then divide the river into a river style approach we applied. And this is the well-known approach. You look for the landscape scale processes, valley setting, and then the geomorphic units. And there are the different classification approaches there to understand that which is it possible to define the whole river system into different reaches, and then can we say about the sensitivity of reaches in terms of the distribution, in terms of the disturbances maybe because of the human impact, that is NCR, or maybe for the future aspect when we put the climate model superimposed over that part. So these are the details of the geomorphic models and geomorphic mapping, and the yellow color is the floodplain areas. We have talked about the river corridor. So you can see the river corridor is quite variable. Somewhere it is 10 to 15 kilometer wide. Some other places it is very narrow. Then again in the badland area it just disappeared. It's become very narrow. So there's a lots of diversity which is there, and that diversity has been mapped and then analyzed. These are the details, but only to highlight that the different types of river style have been identified, and which is the function of landscape scale to geomorphic scale. So it takes care of the geomorphic scale, valley setting, floodplain, and then the geomorphic unit reach scale variability up to the grain size scale is there. So that's my last slide to highlight this part. So that's the different classes we got. We also got the explanation that what other things are there. So these are the different names. And these are the reasons. So there is the stream power and unit stream power variations are there. There is a stream sediment supply variability. So you can see there is a significant differences there from one river style to another river style, and that changes because of the geological condition or major thrust. So that's in the Himalayan part. The valley settings are different, and so you can see that the major difference is there. But once in the alluvial plain is there, are the reasons of the fault. All those processes are there, but the overlapping stream power values are very close to each other. So it means a minor change in the stream power can bring to the changes in the geomorphic system. And earlier talk we have seen that geomorphic system change can lead to the ecosystem changes are there. So these kind of river system are much more sensitive to any external change compared to the other type of system, and that's how we come out with some notion of the resilient and the sensitive scale. So the whole reach. So suppose if we talk about disturbances, it may be human or it may be climate. It's not that the whole river system will respond in a similar way. It is the different reaches will respond in a different way. And this first set of understanding is showing that, okay, these are some of the reaches which are sensitive, and these are the reaches where the groundwater, at least some of the places, where the groundwater is playing an important role, like the similar kind of the analysis we would like to do for the downstream. But at least from mountain front to Delhi area, it is showing that groundwater is playing a role. So whatever the flux variation is coming, it may be by the human in their disturbances or maybe by the climate change. These reaches are going to be sensitive geomorphologically, and that will have its impact on the ecosystem part is there. Downstream part, the stream power variation is there. It is much more higher values are there. But what we find out that any major changes in the semi-arid part, which is the Chambal and Betwa river, that will have a direct impact on the river health of this part. So it is sensitive because of the tributary nature is there. So sensitivity is also different. Otherwise, in the Himalayan part, not much changes will happen in terms of the geomorphological part. So with this, I will end my talk. So major conclusion is there that for river health analysis, we have to understand we have to consider the 3D structure of a river basin for the river basin management. We used to piece those things to our place, but we have to bring this aspect in the management application part. And somehow the groundwater river water connection has not that well studies on the Indian river system, and this is now time to understand. So initial studies has shown that groundwater may play an important role on many other river systems as well. So groundwater in Yamuna river system is playing an important role, and on the geomorphic processes and on the river corridor part is there. And disconnection with the Himalayan and strong connection with the Kraton needs to be considered for the stream management part. So this river is very, very different river system. It is not just like, and it is not just one basic scale approach will work. We have to understand the source sensing dimension and what kind of connectivity is there. Second part is that once we have the connectivity, it needs to be applied on the physical system. And based on the physical mapping, we know that some of the reaches are sensitive, some of the reaches are not that, or maybe resilient, we will say. Hence, disconnection will have more severe impact on the geomorphic processes, hence on the river health, and those sensitive reaches needs to be focused on this part. And because this is our main theme of the talk is there, what we highlighted that one approach is not sufficient to achieve any results, and in this work I have highlighted field work I put at the first. So a combination of field work, geochemistry work, GIS, remote sensing and hydrology integration with the stream power component is there, and a framework in the geomorphology will help us to understand this part. We have to have more and more such integration of the different dimensions, but this is just a small integration to highlight this. Thank you.
Long live India and France friendship.